one definite integral. Especially what I would like to show you is the setup. Of course, we have evaluated this same integral before. Let's put limits of integration and let's do the setup again just for practice. Why not? So in this case, using Lyautey, which one is going to be the u? X. That means dv with equals to sine 2x with respect x. Well, the derivative of u, that's du equals dx, and v equals negative cosine 2x times 1/2. Those are the parts that comprise the integration for this problem. Now let's put them together using the integration by parts formula. That means u times v, x times negative 1/2 cosine 2x and minus the integral of v, which is negative 1/2 cosine 2x du. No, not du, actually it's dx. Okay, on notes on notation here. So for the first term that no longer contains any integral sign or differential, so this is where we just put the bar, go from 0 to pi over 4, and keep writing down the limits over here. Okay, we're going to leave this evaluation of the limits until the end. You don't have to do them on the fly. We can wait until we get the very final answer, and then from there just do the upper limit minus lower limit. So, okay, because number one, we still need to clean up some parentheses. Plus the 1/2 the integral 0 to pi over 4. And that's cosine 2x dx. So negative 1/2 x cosine 2x from 0 to pi over 4. And that's okay, the integral of cosine, which is sine, times that one factor of 1/2 that multiplies the other factor of 1/2 that was already there. That should be 1/4. All right. Well, in this case, actually no need for this one over here. We can just, now that we have the integral from 0 to pi over 4. And from here, let's do the upper limit minus lower limit, fundamental theorem of calculus. So, negative 1/2 times pi over 4. Wherever we see the letter x, we replace with pi over 4. Plus 1/4 sine 2x. Well, that's 2 times pi over 4. Minus, okay. What's going to happen in this case?
Oh, you forgot the 2 next to the cosine.
The 2 next to the cosine. Yes, right here, right?
Mm-hmm.
Thank you. Let me rewrite it. Okay, so let's look at the lower limit. 0. Do we all agree that if we plug in that 0 here, regardless of what's next, that's going to get zeroed out? Same over here, sine of 2 times 0 is 0. In this situation, you don't have to show me the evaluation at 0. You can do this in your head and call it a big 0. Alright? That's fine. And this is just to save some work, you know, in a situation in which you are in a hurry doing a homework, where you're doing your scratch work or on the exam. That's fine. Okay, so let's simplify this one right here. So, okay, pi over 4 times negative 1/2. So that's a negative pi over 8. And cosine of 2 pi over 4. But 2 pi over 4 is pi over 2. What's cosine of pi over 2? That's 1. And 1/4 sine of 2 pi over 4, which is pi over 2. What's sine of pi over 2?
1.
That's the one that is 1, I believe, right? I think this one is a 0 one. Cosine of pi over 0, that's the x value on the unit circle corresponding to a 0. And our final answer, 1/4. Right? Questions? All right, let's see what's next. Okay, so later in this chapter, in methods of integration, we're going to look at a section in which we will use tables of formulas to integrate given integrals that don't really look exactly easy to visualize, and come up with a method. And those formulas actually come from the methods that we will discuss, like in this case, integration by parts, trigonometric integration, trigonometric substitution, partial fraction decomposition. So in this case, let's have like a very, very intro to what we're gonna do at that time. All right, so